Hello friends, in this video we have come up with the latest question which has appeared in the GATE exam of electrical engineering in 2023. So here we are given this circuit here and we are asked to calculate the instantaneous value of Thevenin's equivalent voltage across the load terminals A and B at time t equals to 5 milliseconds. So let's see how we can calculate this. So let's consider this part of the circuit here. This circuit closely resembles something which is a current source, and this part you can easily take up as the impedance Z. Now if somehow we are able to apply the Ohm's law here, which says that V equals to IZ, that means we can convert this current source into the voltage source. Now to perform this conversion, we need a single value of I, and let's take it the maximum value for I. So how you will be able to calculate the maximum value? You are given I as equal to sine 1000 t. The constant value which is appearing here is 1. So that means that will be the maximum value. So the maximum value for current is 1 amperes. Consider this value, and Z is 10 plus J10 ohms, and upon using this expression you will be able to get the value for voltage source as 10 plus J10 volts, and this impedance which is appearing in parallel to this current source will now appear in series to this voltage source. So now the simplified circuit will somehow look like this. Now what we are intended to calculate here, we have to calculate the value for the Thevenin's voltage VTH, and if you consider the small loop here, we can apply Kirchhoff's voltage law. So Kirchhoff's voltage law says that VTH is equal to 10 Ix plus this J minus J10 Ix. Okay, so this is what we are able to get. VTH is equal to Ix 10 minus J10. This is what we have to calculate. So now here what we have to do is to find the value for Ix. For that purpose, let's consider this big loop here where the current Ix is flowing and apply Kirchhoff's voltage law here. So let's start with the voltage source. So the value for voltage source is 10 plus J10, which is written here. This impedance is 10 plus J10, but because it is impedance, it is passive, so it is associated with the negative sign. So minus of 10 plus J10 into Ix. Then there is a dependent voltage source, the value of which is 4Ix. So as per the polarity, the direction of current is like this. So we will be taking the potential to be positive, and that is why it is written as plus 4Ix. Then the last branch, we are having the impedance as 10 minus J10 ohms. So that is what is written here, minus of 10 minus J10 into Ix, and this is equated to 0. Now this is a single equation and the only variable which is appearing here is Ix. So upon solving this equation, you will be able to get the value for Ix like this. And now if you are going to substitute this value of Ix in this expression here, so you will get something like this, and upon solving, the value for VTH is going to be 12.5 volts. Now this 12.5 volts is the maximum value of the voltage source. So that means you have to put it in the expression form, and that means that the final expression will now become 12.5 sine of 1000 t. So this is the final expression for the Thevenin's voltage. Now we are given in the question that we have to find the Thevenin's voltage at time equals to 5 milliseconds. So 5 milliseconds is equal to 5 into 10 to the power minus 3 seconds. And this is what you are going to substitute in this particular expression here. So 12.5 sine of 1000 into 5 into 10 to the power minus 3. If you are going to calculate the value for this, you will be able to get the value as minus 11.98 volts, which is rounded off to the second decimal place as per the requirement, and this is what was asked in the question. So I hope you have understood how you will be able to calculate the Thevenin's voltage simply by applying some simple concepts, like we have used source transformation, then we have taken up the maximum value to calculate the value for the voltage source, and in the end what you have calculated is the maximum value for the Thevenin's voltage and you have put it up in the final expression. So just remember these simple concepts and tips and tricks to calculate more such circuits and the values which are asked in the GATE exams. So thank you and happy learning.